Okay, so I think we're ready to go, Lila?
Yes.
Okay, great. So thank you. And thanks, everybody. We've got a good number of people here. Thank you all for joining today. And we're going to keep this moving. First of all, I want to thank all of GSAP and Lila specifically, and to also the Public Design Commission for supporting this research and publication and event. And to Rahul Gupta, who's an MArch student at GSAP, who edited and assembled the materials and was in the original seminar. And as well to Andrea Tonch, who was the TA and is an associate in our office, who produced part of the PDC's Designing New York series with support of Columbia PDC, and the book, which also features, as we go to the next slide, contributions from GSAP students in the seminar. So Designing New York, prefabrication in the public realm, and that's really our key tag that I want to focus on here today. I'm going to introduce briefly, and then we're going to hear from our guests and then have some discussion. This discussion, which was published and launched recently as a collaboration between both Columbia University and the New York City Public Design Commission, is available as a free download. We've got it posted here on our website. In the chat, I should say, and also here. And it examines how prefabrication practices can be applied to small-scale urban infrastructure projects to have, and here's what's important, large public realm impact. That's really what we're interested in here. It also presents current best practices for prefabrication and analyzes both technical and logistical nuances of these systems in order to further understand their viability in New York. So that's also a key issue for us, is that viability in New York. So today we've invited 4 designers from around the world, which is really exciting, who will present their projects that are highlighted in the publication, along with perhaps others, and together with some discussion to further open up the issues and the projects and the future of prefabrication practices in densely populated and expanding urban metropolises like New York City. So that's also kind of our key lens that we're looking at. And this is all in order to meet our growing needs, both in responses to climate change and COVID, and we have some examples of that for public infrastructure, which are also addressing pressures to expedite timelines and reduce costs, which is always the case when you build something. So these are all projects that are built. Shown here in the image is a project on our cover by Garrison Architects, a New York architectural firm. It's designed in response to Superstorm Sandy. There were 34 flood-proof structures at 13 sites that were built. Here is shown at Coney Island and other citywide waterfront sites. They were constructed in 5 months with 1 month installation, and it had a lot of help from an administration that was very keen on doing this. We focused on recent developments that have evolved in the last 10 years. And one of our models as we began was the 2008 MoMA exhibition and publication, Home Delivery, that's shown here, Fabricating the Modern Dwelling, which was curated by Barry Bergdahl of GSAP and Peter Christensen. There are many examples of houses and housing when you start to look at prefab and modular, but less so of public infrastructure. So that's where really is our starting point, kind of last 10 years, public infrastructure. And I want to start by showing a few projects, just a few that are in kind of key projects that are in the publication before we go to our guests. And I'll just do those quickly just to kind of give us kind of more material here to think about. So this Vanessa Library and Culture House by Helen and Head Architects in Vanessa, Norway, was constructed on a very constrained urban site. If you see it, it's really interesting. It was shown here is some of the construction sequence, and it's a glulam wood construction structural ribs that you see. What's really interesting is how those are then creating these kind of reading caves or shelving, both, so that the rib is the structure, it creates the shelving, it creates this reading cave. So that was one of our examples that we had used as a kind of exemplary model in our publication. And then this Lakia Auditorium by Renzo Piano Building Workshop in Lakia, Italy. This is a very remote site, and it is a wood construction, a timber frame and a laminate wood facade. So all these laminates. So you're not really getting the full effect, but this is kind of in a really mountainous area. It's kind of up by itself. So the thing is brought in as a total piece, and then these laminate strips are put on. The foundation was already there, or not already there. That was obviously part of the first construction that you see in the first diagram. So this is a kind of super interesting structure. And then we have to show this project. It is a house, it is a dwelling, but I can't not show this project because it's constructed of infrastructure pieces that are kind of left over, let's say. It's the Hemeraroscopium project. It's by the Ensemble Studio. It's in Madrid, Spain, made of precast steel and glass, factory assembled 4 months, big pieces brought to the site, 1 month on the site for assembly. So this is like a small building trying to be a lot bigger than it is by being made of pieces of highway infrastructure, which, is incredibly cool, I think. This project in a completely other location, site and climate in Phoenix, Arizona, called the Power Parasol at Lot 39. Lot 39 is an existing parking lot next to a very large stadium where a lot of baseball teams practice in the off season, by DiPolo Architects. It is 217,000 square feet of civic shade. And it's both an energy generator and a billboard. Di Bartolo has patented the connection pieces. It's made of a galvanized steel structure with bolted connections. And it allows for, which when somebody thinks about something, if you're ever doing something like this, is how do you maintain it? How do you swap out panels when they're not functioning? Everything, all of these 7,600 photovoltaic panels that cover this existing parking lot for 800 cars can be serviced from below. So that's a really kind of key element also in this design. It's really, really beautiful. I've been there, and if you go to Phoenix, check it out. It's fantastic. We need this in New York. I'm trying to get this in New York. I'm not having success yet. I'm still working with the design commission. This is a whole other scale, something that is constructed in 5 days in a site in an existing kind of auditorium space, paper partition system by Shigeru Ban and his Voluntary Architects Network in Yokohama, Japan. 5-day assembly on site, his cardboard tubes, his paper tube construction where he's patented connections, fabric. And so what is this? It's actually having to do with, it's a COVID response, but it's not where COVID people are. It's for people who, this typically in all-night cafes in Yokohama, they provide shelter for people, offering them couches, computers, and some showering facilities for people who stay overnight at an affordable price. With the surge of COVID-19, the authorities shut down these cafes, leaving people homeless. So Shigeru's Voluntary Architects Network came up with this system to house people who are temporarily dislocated from these cafe spaces, which is, I think, incredibly cool. Shigeru also, and you may have seen this, I think was in the New York Times, but it's not in our book yet, but we want to put it in our book, is public toilets. That there was a competition in Tokyo for comfort stations in public spaces, specifically for the 2020 Olympics. And this is a controversial design that won. I still don't know if it's going to be actually constructed. This is one that is constructed. It's using a tinted smart glass wall, which creates transparent effects when it's not in view. I don't know if this is working, if we click on this or if the next, there it is. So it makes translucent, goes from translucent to transparent with this electrified glass. And Shigeru's comment is that, everybody can see how clean it is. Like, who wants to go into a public restroom when you have no idea what it looks like? Do I want to open this door? And so you can see inside before you actually go in, which is incredibly cool. So those are our examples, and I want to introduce Rebecca Makla, who is our my partner in crime here on this whole project, and Rebecca Maklis, and she is a senior urban design manager at the Public Art Commission for New York, and she's going to tell us a little bit about that and other things that we do there.
Thank you, Lori, and thank you, GSAP, and for having us, and everyone in the audience for carving out some time in your afternoon. Firstly, apologies, there's local law 11 happening outside my window, so I'm going to keep it brief for the noise and to save room for the discussion. So I just wanted to provide a little bit of background on the Design Commission and our Designing New York initiative and effort, and how this research into prefab fits in to our work and charge and partnership with GSAP. So as some of you may know, PDC is New York City's design review agency. And so we review hundreds of projects a year, ranging from large scale mixed use developments to small public infrastructure projects like kiosks or street furnishing. Our mission is to advocate for innovative, sustainable, and equitable design of public spaces and civic structures across all 5 boroughs, with the goal of improving the public realm. To support One NYC and the administration's goals, and to provide guidance on how to meet high design standards with equitable and economical urban development, PDC launched a series a few years ago, Designing New York. Designing New York Quality Affordable Housing was our first in this little series that we have going on, and it was focused on affordable housing and presented design guidelines and case studies advocating for cost-effective and site-sensitive approaches to holistically design quality affordable housing. Excuse me. I'll go through. I'll realize I owe some links in the chat, so I'll share a link to our prefab publication to download and to that in the chat later. So Designing New York Prefab in the Public Realm is the second in this series, and as Lori mentioned, the research started a couple years ago in 2019 with a seminar that Lori spearheaded, and thank you, Raul and Andrea and all the students for really leading the charge on this work. We realized at the Design Commission that we were seeing a lot of city agencies really pushing in a critical moment to develop capital projects, but with mounting pressures of reducing costs and time and all these things that Lori was speaking to. And so prefab and modular and flat pack and these methods were really popping up in our project review more and more starting in 2018, 2019. So at Design Commission, we thought that we could use the Designing New York series to kind of take a proactive approach to start navigating, defining, showing for the capital agencies and with capital agencies what is possible for these non-traditional building methods. As an agency, we're committed to working creatively within the parameters facing public works, whether it's a small kiosk or large citywide solution for solar infrastructure. As Lori was saying, we're pushing for prefab for solar infrastructure for some of these projects. The DeBartolo project is so great. And although housing is so critical and prefab as an industry is really being pushed with the affordable housing market and housing and hotels, we really wanted to use this body of research as an opportunity to focus on programs in the city's civic portfolio that emphasized public realm enhancements and what community benefits could really be achieved through these non-traditional building methods. Now more than ever, amidst COVID, amidst the budget crisis, compounded pressures, even more so to reduce cost and timeline and even control construction environments in the pandemic and safe environments, the city's embarking on design build as well. So we really want to learn more about how prefab can have a seat at this table and be a tool for quality design. So I really hope that we can dive into this all in conversation. Just a final plug, we're developing our third Designing New York series, Streetscape for Wellness. So I'll stay tuned for more on that, and I'll also share that in the chat. So I'll hand it back to Lori. Thank you, and we'll kick off the presentation.
Great. So as Rebecca mentioned, I think one of the things when this all started, we saw this horrible trailer that was going into a park in Brooklyn. I was so upset. I was so sad. And I think the city councilman really wanted comfort station in his park. And, we're all very sympathetic with that. But, why can't we have good design when we're providing something very quickly? Because we all know these things, once they get there, they don't go away very quickly. right? So they end up staying for a long time. And I think every borough in the city deserves exemplary design. And that's one of the things we're really here to promote. So we have 4 really exemplary designers here today, which is I'm really excited about. So I'm going to just introduce them when they speak, but we have Ronnie Markison, co-founder of Human Habitat, Ben Boucher as principal of Brute Deluxe, Adatola, co-founding principal with Giuseppe Lagnano of Lotec, and Carlo Ratti of Carlo Ratti Associati. So, and I know that Rui Guan, who is a 217 GSAP alum, is going to present the work first of Carlo Ratti. He's an associate designer and design lead at Carlo Ratti Associati. So we'll start with Ronnie Markison, co-founder of Human Habitat. And just to give a brief intro to them, and then I'm going to turn it over to you, Ronnie. They are a design build studio based in Copenhagen and New York. The firm embraces cradle to cradle philosophy of design and production products in that, what does that mean? At the end of their life, they can be truly recycled or upcycled. That's another term we'll probably hear, emulating nature's cycle, where everything is either recycled or returned to the earth directly or indirectly as food, as a completely safe, non-toxic, and holistic sustainability. So that's really their agenda. The firm engages in the circular economy revolution and is committed to creating ecologically vital and socially vibrant communities. So when we were searching, we were really so keen on you're going to see their work, and I'll hand it over to Ronnie. We're so keen on what they're doing.
Well, yes, thank you, everybody. I'm going to share my screen here. And well, I'm Ronnie Marcus, and I'm from Human Habitat, and this is my presentation. What are the best projects we can design to improve our cities right now? And how do we build it in the most effective and sustainable way possible? Obviously, there's not just one answer to these questions. I'm going to present to you a small-scale farm we did a few years back called the Impact Farm. In 2014, I moved to New York with my business partner to study urban farming in a big city content. Our intention was to learn about the benefits of growing food in the city and create a project that would bridge architecture and urban food production. In these years, we are witnessing a rapid population growth, a dramatic rate of urbanization, accelerating climate change, and health issues. Agriculture and our food supply is a large part of the challenges we face in the world right now, and so it must be part of the solutions too. In all major cities around the world, different organizations and small businesses are responding to these challenges by growing food and creating jobs with social benefits to the local community. One of these organizations is Harlem Grown in New York. Harlem Grown is a nonprofit organization founded in 2011 by Tony Hillary, and their mission is to inspire youth to lead healthy and ambitious life through mentorship and hands-on education in urban farming, sustainability, and nutrition. They operate local farms in Harlem and have created garden-based development programs for elementary students. They have transformed 12 abandoned lots into thriving urban gardens, ranging from soil-based farms, hydroponic greenhouses, and school gardens. Urban farming is much more than just growing food. It's a way to positively impact the entire community through mentorship, education, and partnerships to create sustainable change. Harlem Grown's story is truly inspirational, and there are people all over the world who are making a positive impact in their local community through urban gardening. So we ask ourselves the question, how can we help organizations like Harlem Grown through design and architecture? We wanted to create a small-scale urban farm that could easily be implemented into the urban landscape. The design had to successfully combine eco-effective food production along with a social space that could be used in all the amazing work an organization like Harlem Grown are providing for the community. We came up with the idea of the impact farm. It's a 2-story greenhouse built around a shipping container. The whole project is designed as a prefabricated flat pack farm where all of the component fits into the 20-foot shipping container. The ground floor is used as a social space and there's a technical area in the shipping container. And the upper floor is used for growing food with a vertical hydroponic growing system called ZipGrow Towers, developed by a US company called Brute Deluxe. One of the key design features relevant to this conversation is our construction method that is designed for disassembly. Most urban gardens around the world are developed on borrowed land where there can be a limited time frame to operate under. By addressing this issue in the design process, we were able to create an urban farm that can be used both as a permanent and temporary structure. This approach has many benefits, both in construction, but also from a sustainability point of view. One day, the materials used in any project will have served its purposes, and from our current way of thinking, become waste. Designing for disassembly means that all materials can be easier repaired, recovered, and reused. All over our cities today, we see old salvage materials being used for interiors in coffee shops, cafes, restaurants, etc. What materials are we leaving for future generations to use in their projects? I think it's important to have that in mind when designing and building any project right now. In 2015, we built our prototype of the impact farm in Copenhagen as a temporary structure with a lease of 1.5 years. During that period, we held different food events and attracted visitors from all around the world who wanted to be inspired and learn about urban farming. After the lease was up, we disassembled the project, packed it in the container, and stored it until we could find a new spot for it. The project later got funded to be upgraded in design and in technical things, and it was built at a local school in Copenhagen, and it's now being used for educational purposes. After we had built a farm and the prototype in Copenhagen, we got commissioned by Harlem Grown to build a farm on their new lot on 127th Street in Harlem. We had learned a lot from the project in Copenhagen, both in terms of how the farm operates, but also how it was put together. All of these upgrades got implemented into the new design. We used a 3D model and we created a 3D timeframe with a step-to-step guidance of how it was put together for the local contractor. The project got prefabricated at a local art factory in Copenhagen. All the materials were packed in the container and it was shipped to New York, and then it was transported on site. After the arrival of the container, the farm got assembled by a local contractor. Since all of the building's materials were prefabricated off-site, the whole project was put together in less than 3 weeks. One of the huge benefits with this building method, besides time, is that we didn't create any waste materials on the building site, and there was no adjustment to the prefabricated building component. It was simply a matter of connecting the different components together using bolts and screws. Since the farm was completed in 2018, it has produced food year-round. All of the food are being distributed to the local community for free. It is being maintained by a farm manager, the children, families, and community members who come together to learn and work with Harlem Grown each day. Through this pilot project, Harlem Grown hopes to present a viable model for replication that can help to increase access to farm-fresh produce throughout lower-income neighborhoods in the urban landscape. Harlem Grown's vision is to transform this space into an innovative urban agriculture center and green oasis for the Harlem community. Thank you. That was my presentation.
Thank you, Ronnie. And I'm coming back on the screen. Thanks so much. And it gives us things to discuss as we go forward. So Ben Boucher from Brute Deluxe. Brute Deluxe is, here he is. It's an architecture and design studio based in Madrid and Munich. It's an extremely interesting model. So we saw one model there where they're in New York and Copenhagen, 2 people working, bring the project from there. Brute is really a hybrid practice. I'm going to call you guys a hybrid practice. They're focused on, and this is to quote you guys, the investigation and creation of space and its atmospheric qualities.
Yes.
You'll see why. So their projects engage in a huge range of scales of urban intervention, from ephemeral artistic installations, industrial design, construction design, and urbanism, and also those components in urbanism, we could say in cities. They're truly a multidisciplinary team. If you look at their website, I haven't seen many firms that have that many disciplines represented. They have architects, okay, check, but they have artists, graphic designers, structural and digital engineers, landscape architect, art historian, anthropologist, and historian. So they're all engaged, depending on a project's objectives, as I understand, in the design process. So Brute Deluxe combines both scientific and artistic strategies in their creative process. So I'm going to hand it over to Ben. Thank you so much for coming all the way to Colombia. Yes.
Thank you for the invitation.
Mm-hmm.
And yes, that's it. So I'm Ben Boucher, I'm the head of Brute Deluxe, and I was asked to present one of our urban furniture pieces, the kiosk Empoli, and it's a direct commission by the city of Madrid, and it's a kiosk for temporary street markets. And when you think about like typical structures that are used for temporary street markets, you usually have structures by wood or by textile structures, and they take like 1 or 2 days to set up, and the same happens once the street market is over. You need another 1 or 2 days to disassemble them. So the premise of this design is to have a ready-made kiosk which can be brought as one piece on site. This by transportation directly gives us a dimension of 2 by 3, and when it's closed, it's sort of a box with this gabled roof, and we called it Empoli in reference to the board game Monopoly, which is sort of you have these house pieces, and this one sort of remembers those pieces from the board game, but then sort of we have this one big element to open up the facade, and when it's flipped open 90 degrees, the element protects from sun and rain, and when it's open 180 degrees, the house converts into a house with a chimney, and at night like a big billboard, right? So we did a lot of testing also with the possibilities of the layout schemes on the different squares you could have on site. And the interesting part about this project for us as designers is that we started at the same time with the construction drawings, and we had a company to set up a mock-up in 1:1 scale. So this is like our first drawings to, well, define the geometry and how it works, and it's basically a one space unit, so it's rather defining sort of a little bit detail work. And at the same time, the fabricator started with this mock-up, which you can see here. It works a little bit like a car chassis, actually. So you have this framework, and it works together with the metal sheets to give it stability. And well, this goes actually quite fast. Like after 2-3 weeks, we have something that already looks quite finished. And as a designer, we noticed that like at this point, we have 2 big challenges. One one of the challenges the opening mechanism, which it sounds sort of easy to flip up an element 180 degrees, but it's actually quite difficult. And so we started drawing an element which sort of pushes this open. This works with a motor and like a screw or drill element, and pushing it up with sort of like well, I don't know how the mechanism is called. This worked, but it did create some tensions on the element. So finally, we came up together in collaboration with a company and with mechanical engineers with a system that works with 2 hydraulic pistons. One is pushing up 90 degrees, acting on this arm, and the other one is opening up the element 180 degrees in the end. And the second big challenge of this project is, in contrast to the very abstract and archetypal form, we wanted a very delicate finishing for the facade. And it was clear that we wanted metal sheets. This works good for vandalism and it's good for recycling as well. So we took this metal tree drawing and made it sort of an abstract pattern, which is then applied on all the facade elements. And this is only possible when you work in collaboration with a fabricator to make those tests and experiments, and when you have a large number of units. So here you can see like a prior state. This is actually like the car chassis with all this is the waterproof element, which goes as a whole block into an oven and is weatherproof, and the insulation is applied on the interior, and the facade is coming afterwards. It's like an additional element. This looks sort of finished, but this is like with the placeholder for the facade. And for the interiors, we choose an adaptation of a commercial system to be able to exhibit all type of products you might want to show there. And this is the finished mock-up. When it's closed, it looks very abstract. And then this element lifts up like 90 degrees and 180 degrees. And this is the final element to push this up. And well, I think sort of we focused on the finishing material. It's corten steel with this mechanically pushed in pattern. The corten steel starts to oxidate after a while and gets this beautiful pattern. And as Laurie said, so we are very interested in the atmosphere, and we like this image very much. It's sort of the expectation you create at night, what might be in such a small hut, and then at night it turns into something very different, like a billboard effect. And well, once we had sort of we had finished the whole construction design and the mock-up, and we showed it to the city of Madrid. And this, yeah, that's like the first element finished. And then we got the contract to build 275 units. So that's when actually sort of the fabrication process starts, and you have all those elements at the same time. There's still a lot of optimization done and experimentation, because we do an execution project actually of each sheet. And when we saw this, well, we started again sort of with variations like the interior colors. We have 8 different colors for the interiors. That's very easy to do. And this is all at the fabricator's site for the pieces waiting to get transported on a truck to Madrid. And when we saw this, we also asked the city of Madrid to apply different facade materials. So in the end, we have also this stainless steel elements, which of course transforms the perception of the piece completely. And with these mirror effects and the rain on the facade. And we have black lacquered pieces. This is easy to do because the facade material, as I said, is just like it's easy to change. You apply it afterwards. This is brushed aluminum. So then the whole sense of this is to be able to transport the pieces on a truck, and you would be able to reassemble a street market just in 2 hours at night, and you can just move them around. You just have to plug them in. And well, if you think about like the appearance, the perception of typical street markets when they're not in use, I think at least it's sort of very different from the installation we did for those pieces in Madrid. And this, of course, changes completely when they open up and sort of the product takes all the protagonism, as that's what is wanted. And this project, well, it's a little bit older. It worked fine during 5 years, and then we had the financial crisis. The city of Madrid bought these 275 units, and they had a contract for the maintenance and the setup. And well, with the financial crisis, they didn't have enough money anymore, so they terminated this contract. And now the kiosks are placed in public schools, public sports facilities, and public gardens, parks, etc. And they're just used as storage items. So that's a little bit like buying an expensive car and not having enough money for the gas, but they just sort of sit there, and they're used to store the pool items, but it's still a beautiful car. So some of them look a little bit shabby, but they are almost indestructible. So probably they will be there in 50 years. And some of them are kept really nice. And when you come to Madrid, there's really a lot of them, and you just you will cross one for sure. Well, that's sort of the presentation for today. Thank you very much. If you have any questions later on.
Great. Thank you, Ben. It's so cool to see like an expanded development of it and its afterlife, so to speak. Okay, great. So I'm going to also now introduce Adatola and of Lotec. Lotec's known, I think you all know Ada here at Columbia, at GSAP, for their innovative work, specifically with the standard we saw in the first project, the second project, the ISU shipping container. And Lotec is known for its innovative practice and specific focus on this specific shipping container, which is really, to me, is just an amazing thing that they have devoted their work to this, and the amount of creativity that it has expanded into. In their commitment to working with this, I'm calling it the ready-made, in like the Duchamp sense of the ready-made, for their practice. They've explored and adapted this, they say, durable, flexible, and of course, incredibly sustainable object, because they're not going away. They're piled up all over the world, to architectural applications. Their stellar example of upcycling extends the life cycle of these already manufactured objects and expands the potential of existing systems and explores the futures of legacy platforms. So in their design for cultural and institutional projects and residential houses and housing with this component, I think they've just exploded, and it just seems an unending proposition, which I'm really excited to have here. They are the experts of the shipping container, and they've also proposed architecture out of the ready-made, such as cement mixers, I hear, and airplane fuselages. I'd love to see those out of other ready-mades. We're extremely fortunate to have Ada Tola and Giuseppe Lignano as faculty at GSAP, and Ada's here today to join the conversation.
Thank you, Lori. I'll share my screen. Okay, so I would like to start with an acknowledgement to all workers, and also for the indigenous lands we occupy, a quote from Joy Arjo, a writer and poet laureate of the Muskogee Creek Nation that I really, really love. And she says, in reference to sustain the need for artistic expression, I believe that if you do not answer the noise and urgency of your gifts, they will turn on you or drag you down with their immense sadness at being abandoned. So in Low-Tech's case, the word is upcycle. We start with upcycling because of the shipping container, or we start with the shipping container because we must upcycle. We begin with the 320 square foot of perfect Corten steel enclosure, which we drag out of its back of the house, anonymous, unexceptional global network into specific new uses, new massing, new spaces. Because we begin with a volume existing and heavily used before we reclaim it, we work and have always worked off-site as well as on-site. Prefabrication has been with us from day one. I will start by showing you the Whitney Studio. The Whitney Studio upcycles 6 20-foot containers to squeeze into the Whitney Museum Breuer building moat on Madison Avenue and be occupied as a space for art education and art making. A single operation on the assembly slivers the cube diagonally, generating windows and skylights and a double height within. This is the beginning of the off-site work. It begins with selection and then with steel modification. The containers are modified in a shipping container facility, in this case in New Jersey, conveniently closely located, painted black in this case to best interact with the existing Breuer building, which we love, and then inserted with great care into the tight moat of the museum. In the off-site, on-site split, logistics are part of our work. We design and devise the how-to all the way. So you see here the building going inside the Whitney moat, which was quite complex. The building is a landmark. The Whitney is a landmark building. And we had the set of lawyers from the building inside, right behind the window, watching the assembly, which was quite exciting. But we had to devise this system of tracks so that the containers could be positioned and slide down below the cantilever and right next to the bridge of the existing museum. And all of this to say that some of the technicality for us are complex, but also very inspirational. Here you see the building in its final form and the idea of its kind of mute presence that is both interacting and revering the existing building, and how it looked from the inside of the museum, providing a glimpse to the activities within, but also independency, and then the sort of surprise of the interior space with a double height and the white background for art making and art exhibiting. So when the Whitney moved downtown, the building was donated to Socrates Sculpture Park, which obviously is possible only because the structure could be disassembled. This goes to what Ronnie was saying also about moving his parts. The Socrates requested a design expansion that could include a larger art education and exhibition areas and some administrative spaces. So we designed the cubes, which starts from the Whitney Studio and repeats it 3 more times, 2 equal volumes and 1 open and ghosted volume for outdoor use. The building is located right at the entrance of the park, will be located right at the entrance of the park, to the right on this kind of niche amongst trees that is right there, lifted to respond to flooding. And I want to shift your attention to drawings, both as a technical and artistic expression, which for us is a really important overlay. So our construction drawings had to be reconceived as we started working with containers from the onset of our work to include a sort of container schedule. or a catalog of each container that had to be coded and drawn through all its sides. This is the portion of the drawings that goes to the fabrication shop, to the workforce that will be in charge of off-site construction. This is the proper prefab. And this is where knowledge includes also a lot of structural and fabrication knowledge. And I want to bring this up because precisely because we work with containers, we actually had to invent a new form of prefabrication or a sort of construction technology. And this process required a real knowledge share, a deeply collaborative attitude, working with manufacturers on one end and engineers on the other. And what we ask manufacturers, and in particular on the trails of the big American industrial might, we ask them to engage with projects that in stark contrast with the more repetitive setup of their work routine are instead unique, challenging, and different. And what we asked engineers instead on the opposite end is to engage their incredible knowledge to this very elemental application on a simple volume or box, considering its infinite variations and iteration. So the projects rely on this very tight team to allow us to transform this box or boxes as we all operate within existing carbon footprints, from design to engineering to manufacturing and back to design. Shifting attention again, in all of our projects, the connection between the technical and the expressive is a very important connection. And as we produce drawings to understand how to be most efficient and how to not waste anything, as we say, how to kill a pig and use all its parts, we also ask ourselves, can a drawing be prefabricated? Or how can we prefabricate a drawing? How can we make a drawing that is very close to the work itself, that follows the same logic, the logic of the object, rather than the logic of the white sheet or the white screen, the material selection, and the conceptual and physical operation of layering, cutting, removing in our case. Here you see Puma City, which was a particularly complex project because the building had to be assembled and disassembled multiple times at 11,000 square feet of space. And the drawings that we did very much to explain to the trades how we did that ended up also being the drawings that represent the project. This drawing is right now in the MoMA collection and on the MoMA walls very proudly for us, so please go see it. Again, I want to highlight the importance of this connection and also look at these projects for their larger scale. And then one last thing, I want to go back to a home that we just completed that is really a prefab at a bigger level because the modules in this case were completely retrofitted and is an attempt for us to systematize some of our knowledge. So this is a single family home that comprises 6 fully transformed shipping container units, entirely retrofitted prior to the delivery. You can see the kitchen just being deployed with insulated walls, windows, appliances, and fixtures. COM is a pre-designed system that utilizes repetitive spatial solutions and details at different scales to offer a variety of sizes and configurations. This is the house as it exists and is inhabited right now. And I want to conclude just saying that for us, while to prefabricate is really to fabricate before, I would argue that our work is also a sort of a fabricate after. And maybe what Lotec does is post-fabricate, or that we even unfabricate, which is not the same as dismantle, although some dismantling is always necessary and not just from a fabrication standpoint. And with this, I end.
Thank you, Ada. Fantastic. And then we're going to conclude, because I see some questions popping up too, with Carlo Ratti Associati. So Rui Guan is going to present. Oh, there's Carlo. You're here.
No. I've been here listening. Sorry, Rui is based in our New York office, and also he's a Columbia University graduate. So I thought Rui should be there because I was just a bit late at the beginning. So I think it was good for him to be there. And Rui, you could take some of the questions if you want. Okay,
great. So Rui, yes, we're really excited that he's a 2017 GCEP graduate. And so that's fantastic. I don't know if he speaks Italian too, but he's an associate designer and design lead at CRA. So just to give a brief introduction for Carlo Ratti is a professor of urban technologies in the Urban Studies and Planning program at MIT, where he directs this Sensible City Lab. There it is. Carlo Ratti Associati is based in Torino, Italy, and also New York City and London. And the office is currently involved in many projects across the globe with scales ranging from product design installations to architecture and urban planning. The office explores the intersection between the natural and the artificial in the built environment, often leveraging digital technologies as part of a multidisciplinary mission to innovate in the urban landscape. So Carlo, I'll turn it over to you, and thank you for coming to Columbia.
Thank you very much, Lori. It's a great pleasure. You know, under normal condition, I would be there with you in person. I've been many times, and I loved it every time. Now, I changed a little bit my presentation also after seeing the beautiful presentation by Ada. So I wanted to start by sharing with you a project we did actually during the pandemic, at the beginning of the pandemic. You know, at the beginning of the pandemic, we were all asking ourselves, what can we do in order to actually contribute our skills in order to help during the crisis? And so we certainly, so we started a project called Cura, which is connected units for respiratory ailments. And so COVID has changed the way we work, that's for sure. And one of the interesting things is that we started sharing much more. You know, during the crisis, we started sharing much more. This is our, some colleagues at MIT did this kind of event project in open source, and many people started using open sourcing. Even companies like regular companies, commercial ventilators here, companies such as Medtronic, one of the leaders in ventilators, decided to open up design specs and code for free to all. And so we were inspired by this. And we were thinking, what can we do? Well, people focus on different things, but one thing is for sure, this we are talking about last March, but unfortunately, this is still true today. We must expand ICU capacity worldwide. And so we started this in an open source way. The amazing thing is that this was just at the very beginning. We immediately got a team that grew to over 2,000 people involved in the community, helping to design this. And our goal was, is there anything we can do in between those things? So you see, something can be deployed rapidly, would be easy to scale up, would be responsive and agile, but also would allow to have biocontainment inside. One of the tragedies we've seen across the planet is that a lot of makeshift hospitals, were quickly mounted, but then, they didn't have biocontainment, so a lot of people got sick and got COVID at the time. And biocontainment is done by actually creating negative pressure and putting very special filters. So you create negative pressure, that means that all what is inside the container or what is inside the unit doesn't go out. And then you take air out only after sterilizing it with special filters. You can use ozone filters, you can use HEPA filter, very special HEPA filter, and so on. And so anyway, we started with this design. This was the first version, how we could put two intensive care units with biocontainment. And we decided to use containers. I mean, that's why I added the project after, I know Ada's work very well. We also met once at MIT. But so I we said, you know, containers can leverage an amazing infrastructure for building, for making, for moving around the planet, for shipping. You know, one problem also is if you don't use modular structure, it's very difficult to move things from one city to another city. And what we know now about COVID is really that the front line is switching. The front line was in Milan, went to Madrid, went to New York, you know, then one city after another city. So you want to be able to move things fast. So this was actually our first project with containers, but it turned out to work very well. You see here the plan, you can see here the initial design of the section for the initial design. You can see here the exterior and the interior fit out, and, you know, an image of the inside with all the components. That's really 2 intensive care units in a container, you know, very super quick to mount, just half an hour. You put the container, you connect it to power in the other, power a few other things, and then you can also move it very, very quickly. And then, you know, you can do different configurations. You can do an annex to a hospital like this, with an inflatable structure in the middle. You can do a field hospital, as you see here. You can also, you know, make it bigger if you need. And, you know, these are 3 configurations, but you got many others. Now, the interesting thing is that, you know, we started this in March, and just in a few weeks, we had one built. That was also thanks to the sponsorship of a major European bank called UniCredit. And they believed in the project. So we had the first one built and installed, actually in a real hospital. What you see here is a real hospital. You see the inflatable part, you see the inside, and you know, these are some of the images of the container. Here you can see actually to the left, you see some of the other bags in the hospital. And the interesting thing is that, you know, all of this, as I mentioned, was done in open source. And so then we started seeing, still today, there's people all around the world using the drawings and for fabrication, some of them changing things. So these are some of the initial prototypes we saw, some of the initial units we saw, you know, coming from all over the world, people taking our drawings, adapting them for their conditions, maybe changing a few things here and there, or the color. And, you know, again, this happened with projects in the UAEs, in the UK, in Italy, in Greece, in the US, in Canada. One of my favorite was actually a company in Canada. And the main business of this company is actually to produce containers to grow marijuana. But they decided during the pandemic, actually, they would download the drawings from Cura. And instead of doing containers for marijuana, we're doing containers for ICUs, intensive care units. And here you see again, you know, this is another company who's been doing it in the UK, very similar to the one we prototyped, so really copying everything. And for me here, the story was twofold, was probably 2 or 3-fold. You know, first of all, well, we know that today we can fabricate without modularity. The good thing about today is that we can really digitally fabricate without being modular, but sometimes modularity is still important. And if you want to do something, you can move around, they can use the infrastructure we have in our cities, on the planet, you know, ships and so on, cargoes, then modularity is important. So the first point I wanted to make is that, again, even if today we can have, you know, think about Catera, we actually started a similar company in Europe, you know, smaller, much smaller company, but, you know, we can fabricate whatever we want without modularity. We don't need modularity, but sometimes modularity is important. And that's what we learned with Europrods. Now, the other thing is that open sourcing becomes very interesting. And, you know, open sourcing creates a system where more people can work in parallel, and also you get a lot of feedback loops. You can really speed up a design by open sourcing. And that continues when you start building. You know, people were building and, you know, sharing information. There were some groups on Reddit constantly, it's probably still on. I didn't check them recently, but, you know, we know for sure that many companies are fabricating right now using our drawings. And so open sourcing is interesting. I wanted to make an analogy here. And it's an analogy between the artificial and the natural world. You know, if you think about it, the virus is code that replicates in the taxons. I'm talking about COVID, but every virus and so on. And, you know, in the same process of code, the code of DNA, that then replicates is what is the principle of natural evolution. And if you do open source design, then we're taking a similar approach. Is opening up the code of intelligence, the code of design, and then together we can replicate much faster and fight better. We would never have been able to do this. This, as I said, in just a few weeks, we went to the first prototype in probably 3 months. There were people fabricating this around the world. Well, we could follow a standard system, a standard process, which is, you design it, maybe you patent it, and so on and so forth. The same thing would have taken at least a year. So somehow, by sharing, we can be much, much faster. And the final thing is about feedback loops. The third point I want to mention about feedback loops. Feedback loops are the key things that happen in nature. You try something, you see the feedback, that's what determines if a design in nature is successful or not. And by design, well, maybe I want to say, by the code of an organism. And well, the same we can apply to design. By doing this, we can really open up to a lot of feedback loops, and fabrication allows for this. So anyway, the principles of open source design I want to share with you. By the way, I did a book on open source a few years ago. Actually, the whole book was done in an open source way with different people contributing to it, from John Pabrachan to Joseph Grima to Paolo Antonelli to Nicolas Negroponte to many others, Hans Ulrich Obrist. So if somebody's interested, it came out with Thanks and Hudson a few years ago. But basically, the principle of open source design, share first, no patenting. And competition is good. It's not bad. Anyway, so next steps as well as we're looking at this for the longer term. By the way, so the Global South needs Cura, more Cura still today. And so how can we help them scale up and use the drawings? Mm-hmm. Now, following this, I want to share with you a couple of other experiments. And in these experiments, you use actually a similar approach. As I said before, today we don't need to be modular, but there are some cases when you want a little bit of modularity, and there are some cases where you want to apply another principle. It's actually a principle that was developed by a person who I think was one of the great designers and theorists in the past century, by Dutch architect John Pabrachan. John Pabrachan in the 1970s really worked a lot on how we can involve people more in self-fabrication, or what Enzo Mari called auto-fabrication. And his idea was, in a nutshell, is a bit much more sophisticated, but in a nutshell is, as an architect, you want to provide a framework, and then you allow people to build inside the framework. So you want to give them like a structure, and then they provide infill. Now, this is a very simplified way to summarize John Pabrachan's approach, but just for the sake of conversation, we could talk about this much more if you want in the Q&A. And as I mentioned, John Pabrachan was one also the authors of the book we did an open source design a few years ago. And so I want to share with you very quickly two projects. One is called Living Board. It's a commission from a nonprofit in India. Nonprofit is called We Rise. And We Rise wants to provide housing to a lot of people who today live, unfortunately, in very unhealthy conditions in urban settlements. And so here the idea was, how do you do it? How you provide a structure to them and the basic conditions. And here again, we use a similar approach to the Pabrachan approach, and we called it Living Board. It's similar to the motherboard concept you've got in electronics. So we said, well, if you go there with an element that you can fabricate before you put it on the land, and then you allow people to build their home on it. And you put it on the land. By the way, that's also important because India has been devastated by a few earthquakes recently, and so if you can insulate it from a seismic point of view from the ground, and you put all the expensive things there about services, and then you allow people to build whatever they want above it. And you see it here. So the living board is what you see at the bottom. It has a few extensions that you see there. Also on the top, if you want to put photovoltaics, clearly you need to go to the roof, but basically you allow people to build the shell they want. And you see it here, just, you put this, very simple foundations, depends on where you are. You're getting your seismic insulation, and then you build on top of it. And then you get something like, where you allow people to then make changes and personalize and really do what they're doing today, but making sure that they get the main standards for living. So that's the first one. And actually that happened more or less in parallel to another project where we use a similar approach, again, inspired by the idea of structure and infill. It's an eco retreat on the Himalayas in a beautiful place, very close to Darjeeling and Kalimpong. Just, if you got beautiful views of the Kanchenjunga, an 8,000-meter mountain in Sikkim, the same one that you see from Darjeeling, where the Darjeeling tea comes from. It's a beautiful place with these, waterfalls and tea gardens. And here the idea was very similar. Again, we wanted to involve the local community to help build it. We didn't want to do this, fabricate the whole thing in Mumbai or in Germany, in Italy, and then ship it there. We wanted to involve the local community, but at the same time, the local community doesn't have all the skills to get to the standards that the client wanted to get. And so again, we said, okay, so we fabricate part of it, and that's a frame, and we allow the infill to be produced locally. And again, by involving also local designer, local people. So again, by open sourcing the design, we provided initial design by allowing this to change. This is currently on site as the previous one. And you see it here, some of the possible configurations for this. This was inspired by a lot of the local materials in the region next to Kalimpong. It's not up in the mountains, so even if it's India, weather is very nice, but during the winter can be a bit chilly. Weather is beautiful in January, February, and so on, but it's a cold season, and so that's why you want to have a fireplace as well. It gives you some of the outside. These panels are what is fabricated locally, but also with many variations. That's kind of our initial suggestion, but that's what allows then this to be configured and redeveloped by sharing the drawings. We would share the initial drawings, and then the locals would both fabricate and fabricate with variations. And here's a view during the night, and we really like, especially when the weather is very, very mild all year round, a bit chilly during the winter. Yes, there's a bit of rain, but really the house becomes this kind of very subtle and gentle skin. This almost like, when the lights are on, it almost looks as it's made by paper. So you don't need to have thick walls. That's what the locals do as well with the houses they fabricate. Use wood, and you try to create this very thin surface to protect you from the elements. So anyway, those were some of the things I wanted to share. Again, the things to the key points I wanted to make are about, yes, fabrication can really be very exciting in many contexts. We can fabricate today without modularity, but sometimes modularity is important, as we saw in Cura. And then don't think about using the same system for the whole house. If we open source, we can both open source design, execution, the modification of the design. And then in those cases, it's interesting to think about how we split different parts, maybe a more standard frame that is fabricated, prefabricated, and then infill, which is delegated to other people. So anyway, that's what I want to share with you. I think I've run out of time.
No, it's perfect. We have, if everybody hangs in there, or those who can, we wanted to spend about 20 minutes, or if we can, 15, 20 minutes on some questions for the panelists, and then open it up. And I'm going to start with one that I'm going to combine with one of the questions that we received today. So I guess to start off, I think Ada's there. Maybe she's there somewhere. Anyway, so how has using these systems in the public realm positively impacted both the public and the process? And could you then also touch on some of the misconceptions or negative misconceptions and positive positive aspects that are lesser known? So how have the systems in the public realm positively impacted both the public and the process, right?
Well, the misconception is very simple, right? The container has a stigma for sure.
Mhm.
And right now I would say almost it has a double stigma, because when we started in the early 90s, we were beginning to see shipping containers, and therefore the biggest stigma was the idea of it being this kind of low object, right? That doesn't maybe want to belong to architecture, that belongs to something else. But I think that the second tier is also the fact that now is really the item that symbolizes our global economy. So it has also this added layer as this sort of like background object that we all recognize, but that is really the mule of our economy, is the thing that is doing all the work in global economy. And so in a way, I would say that the most important thing probably is precisely the shift in attitude. I always advocate for the fact that by using ordinary objects, what we are trying to do is first and foremost to allow us as humanity to look at the things that we make, concoct, invent, engineer, and understand ways to think of them through their potential, not just through what they are. So to be able to relook at things with different eyes. And I think our practice tends very much towards that. So it's an idea of, it's interesting, one of the conversation that was very much there through also the other presentation was this idea of how can we reduce waste? How can we reduce waste locally? But for us, it's more how do we reuse waste? So it's even more central, is the idea of we are surrounded by these boxes. And I always think of our work as a work that builds a legacy. I hope that what we will leave, and this goes also to what Carlo was saying, what we will leave is a set of drawings and samples and sketches and the many projects at very large scale that we haven't built, that will stay for humanity in the future to try to understand what to do with this huge amount of steel boxes that are around.
Mm-hmm. Great. Any other comments, responses? Ronnie?
I think,
right? Oh.
Go ahead.
Well, during this whole process that we've been when we've been doing this farming project, we've only noticed from a lot of people that they could see this kind of solution happening many places in the world, and we have been, ever since we did the project, we have gotten responses from all over the world that people want this in their local environment. And I think for us using the shipping container, they've been able to see that even though we've been miles apart from where people are living, that they can still see this kind of solution being implemented in their place. And I don't think we would have succeeded in that if we didn't use the shipping container in our storytelling in what we've been doing. So for us, it has been a very positive response from everybody in terms of prefabrication.
I think somebody else was Ben starting, or no? Was it Carlo? No.
For me, like the biggest advantages about prefabrication actually as a designer is to be able to experiment instead of the typical process where you just design and then you bid and it's built. If you collaborate directly with a fabricator, you can you have a quality control, you can test, you can instead of a one-directional process, you have a process where you're actually sort of testing during months and getting optimization of elements. And of course, you have like the waste. Usually when it's prefabricated, you can disassemble it, and you can you have a much better waste control. So as a designer, it's not like prefabrication is like an object in itself, but it just facilitates a lot of things during the design process.
Okay, great. Carlo?
Yeah, building on that, just a quick thing is, certainly if you want to move to a circular architecture, we need to fabricate. We need to fabricate because then we can have all the elements, we know what they are. In the same way we assemble them, we can disassemble them. But the other thing I wanted to mention that's quite interesting, and might inspire some of the people listening, we had a very interesting convergence we were not aware of. We've been working recently with two colleagues, good friends, with Anton Garcia Abril, who's a colleague at MIT and also the founder of Ensemble Studio. We just finished a project in Europe together, and also with Philip Wan from China, also teaching in the US. And the interesting thing is that without knowing, all the three of us built a factory as an annex to the office. So, we got not a big factory, but a place where we can use digital tool to fabricate. 5 or 10 years ago, all of us would have like, a 3D printer in the office and a laser cutter. And we do the model, started making models inside. Well, even 10 years ago or more. But, that was became the norm everywhere 5 years ago. And I think now, if you take that and you scale it up, I think the biggest one is Anton's one has this kind of beautiful factory he built in Cambridge. Ours is in Italy, Philippines in Shanghai. But basically, it's really that same thing scaled up. And that really, as you've just mentioned, it allows us to test things first, to build more circularity because we can check new assemblies of material. And certainly, I have no doubt that the way we build a home 10 years from now is going to be much more similar to how we build the plane today. Everything is going to come from a factory and then be just mounted perfectly and magically, thanks to the guidance of a digital model.
Mm-hmm.
Also, adding to you, Carlo, I think it's super interesting idea that we can use or like set up this kind of factory network, both in US or in China. We can start with this kind of outsourcing design approach and fast reproduce all these kind of either Cura prototype or other kind of prototype that we can let the world know that all the factory can produce within a certain time frame that we can contribute to the world, either amidst the COVID situation or other situations.
Mm-hmm. Great.
Actually, that perfectly kind of leads into one of the questions that we kind of had repeated from the audience that Laurie and I had chatted about earlier, which is what does, we're talking about a lot of what prefabrication, you all defined it in your own ways, which I thought was really interesting. We in the seminar, one of the first things we did was had to define it from ourselves, like what is prefab, what is flat pack, what is modular, what's the line between it being a component of the typical design, bid, build process versus this new, less traditional method. So one, if you could all speak a little bit more of how you define it for yourselves, and then also speaking to the process and what it enables. Roy, you were just talking about what it enables in a factory setting and process, but thinking of the Public Design Commission's charge and hat, what do you think that then allows in the public realm that perhaps the design, bid, build or more traditional model wouldn't allow as easily to kind of give back and enhance more equitably the public space? Long question, sorry. Super long question.
I guess like prefabrication definitely is quicker and possibly much more kind of accurate compared with traditional building methods. And sometimes it means easy for changes and fast reproduction. And for example, a successful prefab or modular project can be duplicated to many other areas, and so enables a more kind of equitable potential for the public realm. I think the Cura project is the perfect example for that.
I'm also gonna second the idea of obviously the efficiency that is both time and quality control, which is a very important thing. Being someone who practices in New York and having been practicing in New York for almost 30 years, I would add that I think that that's what I was also trying to stress in our presentation, that the very tight connection with fabrication, with who does the work, is a very important thing. And that means that one is to really think about the kind of networks around a potential project. Where does a project exist and what are the networks of fabricators around? In that, I think that in New York, the bidding process is, I mean, this also to respond very much to your idea of like, what are the difficulties? The bidding process that instead wants to be an open process creates a little bit of a crush with the idea of instead precise relationship and precise knowledge. So I think these are the things that one has to tackle with, especially working at public, at the level of the public realm and public projects.
Yeah, exactly.
In my opinion, like prefabrication is so widespread that it's actually just a question of up to what grade you prefabricate. And it's usually limited by transportation, nothing else. If you look at current buildings, it's like most of it is prefabricated, and it's just assembled in a way sort of that you can transport it on the street. On the other hand, sort of if the concepts or misconceptions you have, usually architecture is understood as like site-specific and everlasting, and this goes in contrast to prefabricated, or what people usually understand under prefabrication. When it looks prefabricated, usually it's understood like temporary or like less quality. I think it's absolutely wrong. Like you can prefabricate in a very high standard or even in higher standards, and probably sort of even if authorities would introduce like a requirement for waste management, we would have the entire building like prefabricated, because it definitely makes it easier to disassemble. So it's rather, when you design, it's rather a question about sort of how, up to what grade do you introduce sort of the prefabrication in the building structure, or in the transportation, or in your own like perception of the building. The more you reduce, the less materials you would use, the easier it is to make it prefabricated.
I mean,
I know, Carlo, I was just saying, do you think the line now is so blurred? Is it an outdated term? And kind of bundling that in with the other questions.
Yes, but Rebecca,
realize that we think we're using an outdated term. We think we're using an outdated term, and as I think is another sort of noted.
But Lori and Rebecca, I think what some of your work and what some of GSAP could really contribute to is to actually get a better terminology, because what was mentioned now is totally right. You say prefabrication, that goes back initially to the modular by Le Corbusier, and then to all those experiments that failed. And they failed precisely because they were low quality. They didn't have the flexibility to adapt neither to the environmental condition nor to the living conditions inside. Somehow we're talking about something different now. Maybe you want to call it factory fabrication, and that's that you can do something, the same things you can do on site, even more flexibility in terms of variations, and you can do it much higher quality. And let's face it, it's the only way to be circular. There's no industry. If you think about traditional construction, is the most, the least optimized industry. When you make a wall, and then the next week you got people running cables and knocking down parts of the wall, and then you got again people coming to fix the wall. I mean, it's just a mess the way things are built on site. We know it. There was a report by BCG a few years ago that looked at the level of digitization of different industries. Construction was together with hunting and fishing at the lower. So I think the only way we can digitize, be precise, and be circular, and create really amazing buildings is if we embrace factory production. So somehow, I think what you could really help also with this discussion is really get the right terminology, because sometimes people get a bit confused.
Yeah. Absolutely. So are there key roadblocks? I mean, Ada was speaking about this briefly, but that we didn't touch upon in the presentations. Has the design process and roadblocks changed recently? I think Carlos speaks about and Bree speak about kind of working in kind of dual locations. What has changed? What additionally has changed? Because this is all moving so rapidly, and I think people have preconceptions, obviously, about what prefab is. We use the terms to kind of bring people on board, but then we want to take it apart, right? To really say, well, what is this today?
Unions are roadblock. I mean, I'm usually very sympathetic of unions, but in New York, they're blocking a lot of this.
Yeah, I know they had to do lots of cartwheels to get around that for some of the housing and also for Garrison's project. I don't know if Ada has run up against that in terms of, because you have who hooks up the plumbing, who hooks up the electrical to get into all the nitty-gritty of this.
Yeah, but part of it is exactly that this idea of this share, because there's a moment where you have to bring the responsibility, right? In this on-site of site, you have to drop the responsibility in the hands of somebody else. And that's a critical moment, of course, and it requires a huge amount of collaboration. So that's complicated for sure. But I also wanted to say a little bit in response to Carlo and Ben that yes to the factory work as we can, although I was highlighting the issue of network because I do think that transportation is an issue. Transportation impacts the sustainable aspect of the work. So it is not just transparent. I mean, it is not just irrelevant. It's very, very relevant. And that to me is, I want to also give a little bit of pushback because, I know we're talking about New York, and New York is the very first world. So we're all happy to be here. But having worked in South Africa, in Johannesburg, I can tell you that ideas of prefabrications are radically different. And skills of making and technology of transformation are radically different. And part of our task, I think, is also to understand how to respond to very specific conditions, not just to go top down, because we enter realities that have their own richness, and there is an exchange every time we intervene.
Right, I totally agree.
Yeah, and maybe building on that, not location specific, but in the midst of this pandemic, of talking about how can prefabrication respond. Laurie and I were talking before the event of, are there now new ways that we can push both New York and others to go more towards realizing the potential of prefab and modular in the pandemic? Are there pros that we can speak about of front loading certain aspects of the design, kind of delaying others that allow it to optimize in this pandemic condition? Do you think that's a next step and a potential?
Is this specifically a question for me? Yes. I mean, it's interesting. I showed as the last project the house, although it's a residential project and it's not a public project, but it's interesting because it's a project that is getting a lot of friction for us right now, precisely because of that, because it stands in this place where is both pre-designed, but also is very customizable. And I think that there is a real interest right now for people to enter exactly that place where something is not totally done, but some of the thinking has already been pushed ahead. So yes, I think absolutely so.
And since many of you teach, I just want to wrap up with this and be mindful of the time. And we've been trying to incorporate some of the questions that are coming here on the chat. But since many of you teach, and we have a lot of students in the audience, through an educational lens, how can students be pushing the envelope on this topic? So, how would we think differently about this? Are we? Thoughts on that?
I'm going to say very quickly, as you know, having been in school, in the same school, under the same school roof for many years, I'm a big advocate for the fact that students should really try to understand what their personal interest and intention is, and mission in a way. So I think it's very important to expose students to other means and other ways, and to let them really consider what it means right now to practice, and not to just default to default modes. I'll leave it there.
Okay, great.
I would say very quickly, something very trivial, spend more time in the Fab Lab. You know, I learned a lot of this when I was a PhD student at MIT in the very first Fab Lab that Neil Gershenfield did in the basement of the Media Lab. You know, if you're able to manage it in the Fab Lab on a smaller scale, you know, the same thing you can manage is just a bigger machine. You know, you go from the small laser cutter to a big router to cut XLAM, you know, CLT, cross-laminated timber, but it's really the same thing. So very simple, just, you know, spend your nights in the Fab Lab.
Great.
Totally agree with Carlo. I think spend time making, not just on your screen. That's a huge lesson.
Yes.
And not talking, making, not talking. That should be there. Not talking.
Okay. Anybody else here?
I have one.
Ronnie?
Well, yeah, well, so since we did the whole project ourselves from start to finish, so we did all of the, when we started designing the project, we knew that we had to build it at some point. So that, and I have a background in carpentry, so I knew that at some point I would have to stand and put everything together. So that helped me a lot in the way that I needed to think about the project and in terms of how things were put together. So I think it's a good thing to have in mind when you're designing, is that at some point you have to give the drawings to somebody who have to build it. And the simpler you can construct things, and the simpler you can start taking things apart from each other, the better end product I think you can get out of it. So
Great. I don't know, Ben? No? Okay, I'll end and say thank you so much, you four and five, for presenting your incredibly inspiring work to all of us. And, you know, I always say we want to make the world a better place. You know, we're incredible optimists as architects. I mean, we're eternal optimists. And I just, you know, so appreciate the work you've done. And I know it comes with a lot of labor, a lot of extra labor.
Thanks a lot. I hope to see you all very soon in person.
Yes, please.
Yes.
Very soon. We're getting
and send on a good note.
Great. Thank you.
Bye.
Thank you all.
Bye-bye.
you know.
Thanks so much. Thanks to the students.